Section 8.3, we're going to take a look at how to prove that a quadrilateral is a parallelogram. And this section very closely relates to the previous lesson where we talked about the definition of a parallelogram and then the four primary properties of parallelograms. So again, hopefully you're familiar with those properties. Otherwise, you're going to have to take the time to review those if you want to polish up on proving that quadrilaterals are parallelograms. So by the end of today, I want you to be able to use the properties of parallelograms to identify how to prove a figure is a parallelogram. Okay, so as we go forward, there are a few different ways to prove that a quadrilateral is a parallelogram. The first one is to show that both pairs of opposite sides are parallel. Okay, we talked about this already in class yesterday. That's what it means to be a parallelogram. So if I can prove that the opposite sides are parallel, then that is enough to conclude that the figure has to be a parallelogram. Okay. The second way out of 5 that to show that a figure is a parallelogram is to there we go. Okay. Skipped one there. Okay, is to prove that both pairs of opposite sides are congruent. Okay, you have to prove that both pairs of opposite sides, not just one, both. So again, we can prove that opposite sides are parallel. We can prove that opposite sides are congruent. Either one is going to allow us to conclude that the shape is a parallelogram. The third way is to show that both pairs of opposite angles are congruent. And again, you're going to notice all of these are exactly what our properties were yesterday. The fourth way is to show, now this is a new one, okay? This is one that's kind of an outlier that you're going to have to take the time to memorize. This one says that you can show that a quadrilateral is a parallelogram if one pair of opposite sides are parallel and congruent. Okay, so that's the only one really that you're going to have to spend extra time on, because that is not one of the properties that we really talked about with parallelograms, but it is a way to prove that a figure is a parallelogram. And finally, the fifth and final way to show something is a parallelogram is to prove that the diagonals bisect each other. Okay, and you know, you're not going to be expected to construct two-column proofs necessarily, but more so it'll be, hey, if I want to prove that this figure is a parallelogram based on the given information, how would I do that, or how would I go about doing that? Okay, so if you're in my honors geometry class, well, then you're going to have to write out proofs. Okay, so in other words, what they want you to do here, it says which theorem can be used to show that the quadrilateral is a parallelogram. Guys, I want to discourage you from memorizing the theorems in terms of their numbers. Okay, so don't memorize theorem 8.7, 8.8, 8.9. Don't memorize all of those. Very simply, if I look at example 1 part A and they say, why is that thing a parallelogram, or how do you know it's a parallelogram? Okay, well, I know that because diagonals bisect each other. Okay, and that's all I'd be looking for there. I don't need to see theorem 8.10. Okay, just give me, hey, diagonals bisect each other. In part B, how do you know it's a parallelogram? Opposite sides congruent. Okay, that's it. Part C, how do you know that's a parallelogram? Opposite angles congruent. Okay, opposite angles congruent. And finally, part D, how do you know that that's the outlier, right? How do I know that that's a parallelogram? One set of opposite sides parallel and congruent. Okay, that was the outlier. That was the one that I had said that you're going to have to really pay close attention to, because that's kind of an obscure one. All right. So as we move forward here, example 2, they give us a diagram and they tell us that AB and DC represent adjustable supports of a basketball hoop. Explain why AD is always parallel to BC. Okay, and very simply, okay, when I look at this shape right here, okay, the one that I highlighted in blue, if you look at this side, AB is 36, DC is 36. BC is 18, AD is 18. Okay, well, if we go back to what we just talked about, if opposite sides are congruent, then that means that it's a parallelogram. So our conclusion is we can say since actually let's just generalize this a little bit more. Since opposite sides are congruent, A, B, C, D is a parallelogram. All right, ran out of space there. But anyway, okay, so since the opposite sides are congruent, the figure is a parallelogram, and since the figure is a parallelogram, that means that your opposite sides, AD and BC, by definition, are parallel. Okay, I try to get that in there. Let me rewrite that. Okay, so again, AD is parallel to BC. How do I know that? Well, that's what it means to be a parallelogram. So once I've established this figure is a parallelogram, opposite sides have to be parallel. Okay, I'm going to keep buzzing through here. I know we have quite a few examples here to look at, so we're just going to keep kind of going along here. All right, it says the headlights of a car have the shape shown at the right. Explain how you know that angle B is congruent to angle D. And again, it goes back to, hey, look, these sides are parallel and congruent. Therefore, this thing's a parallelogram, and if it's a parallelogram, then we know that one of the properties states that opposite angles are congruent. So you'd have to write all that out. I'm not going to take the time to write it out. So again, how do you know that B and D are congruent? Very simply, we know that ABCD is a parallelogram because there's one set of opposite sides that are parallel and congruent. Once we know it's a parallelogram, then one of the properties that we know says that opposite angles are congruent. So angle B and angle D would have to be congruent here. All right. We have a quadrilateral, and we know that the measure of angle G is 55, H is 125, J is 55, and we want to find the measure of angle K. Well, very simply, right, if I draw this figure, it's a quadrilateral, so it's got four sides, 1, 2, 3, 4. Call it G, H, J, and K, and they give us angle measures, right? 55, 125, 55. They want us to find X. Okay? Well, okay, I can find the measure of angle K. Really, I know the angles in a quadrilateral add up to 360, so I know I have X plus 55 plus 125 plus 55 equals 360. And when you solve this for X, and I'm not going to go through the actual algebra, okay, add up all of those. I believe you're going to get, what, 235, subtract 235 from 360, and you're going to end up at 125 degrees. Okay, so this angle measure is 125. And so now the next part of the question says, what theorem can you use to show that this figure is a parallelogram? Well, if you look at your opposite angles, 55 and 55, 125 and 125, therefore it's a parallelogram. So when it says what theorem, again, I don't want you to recite theorem 8.7 or anything like that. Just say opposite angles congruent. Okay, that's all we're going to say. All right. Explain how you know the quadrilateral is a parallelogram. I'm going to talk through these. I'm not going to write anything out here. So example number 5, part A. How do I know it's a parallelogram? Well, the first thing you'll have to do is actually find the missing angle here. And when you do, you're going to find that the missing angle is 67. Okay? And once I know that, well, opposite angles are congruent. Therefore, it's a parallelogram. Okay? Now, part B, we're going to shift gears. We look, and now we're talking diagonals. If this is 5x and that's 5x, well, then these pieces are congruent. And if this is 3x and 3x, then QP and PS have to be congruent. And so, obviously, in that diagram, I think we can conclude that diagonals bisect each other. Once we know diagonals bisect each other, it's got to be a parallelogram. All right, now we're actually going to do a little bit of solving here. Okay, it says find the value of x if the figure is a parallelogram, okay, or what makes it a parallelogram. So this first one, if this figure is going to be a parallelogram, well, we're talking diagonal, so if these two are congruent, if it's a parallelogram, then these two pieces also have to be congruent. So in part A, all they're wanting you to do is set up the equation 5x equals 2x plus 9. And from here, you all know how to solve this. Subtract your 2x, you end up at 3x equals 9. Divide both sides by the 3, so x equals 3 in example 6, part A. Okay. Part B, no different. The setup's not going to be any different, so I'm not going to actually do it. But again, you're still going back to the idea that diagonals in a parallelogram bisect each other. Okay. And finally, part C, my figure's not up here, but obviously you have yours on your paper, and you can see that FG is 5x plus 2, and JH is 4 parentheses x plus 2. And they tell you that, well, let me just draw the figure here. I know that you guys have it in front of you anyway, but it's just easier to talk about if we have it in front of us. So we have 5x plus 2. We have 4 parentheses x plus 2. And then let's call this F, G, H, and J. Okay, so again, this comes back to the theorem of I know that opposite sides are parallel. If this thing's a parallelogram, then they also have to be congruent. Right? And that's where the equation comes from. Okay, 5x plus 2 is equal to 4 parentheses x plus 2. You know, we're going to have a little bit of a distributive property here. So distribute your 4. So we end up at 5x plus 2 equals 4x plus 8. And I'm going to do 2 steps in one here. I'm going to subtract 4x from both sides. And I'm also going to subtract 2 from both sides. So those will cancel, and those will cancel. And so on the left side, I'm just left with 1x. On the right side, I'm left with 6. Okay, so the value of x in this particular example is 6. And example 7, again, I'm going to let you work through that on your own. That goes back to the diagonals bisecting, and I'm sure you're pretty confident with that now. Okay, so again, as usual, any questions you have on proving figures are parallelograms, bring them with you to class tomorrow, and we'll go over them first thing.